at steady state, what we can say, number of collisions per unit volume in a gas remains constant. This will be later. I'll bring a formula. So time being, okay, you can have this much of thing. Okay, what do you mean by steady state next? Because all our discussion will be at steady state. What do you mean by steady state? Number of collision per unit volume is gas in a gas remains constant. So next one more, I'll add it. The density of gas is constant at all points of weather. Means you calculate the density of gas. If I say density of gas, you should not ask like at which point in a weather. It is assumed everywhere. Okay, 1, 2, 3, 4, 5. So what is the density of gas? Fine. So this is some very much essential. So if I say pressure of gas, so where pressure of gas? You measure at any point, that should be the pressure of gas only. So we should not go and ask also like a where pressure of gas in a vessel. If we say pressure of gas, it is assumed that everywhere pressure is same. The density of gas, that means, so what is the behavior of gas in this region? It will have same behavior everywhere. Are you able to understand? But sir, here they'll be moving to a different speed. Okay, next is telling steady state. So what do you mean by next? We'll go for next conditions here. At steady state, if you look at the distribution of molecules, means if you take some at a given point, I think I need diagram here also. I will take two volumes here. Now, how many molecules that are and like a I'll just do one thing. I'll take here some elemental volume. There are 10 molecules are there. That's one. So what is the speed of the 10 molecules? The same what happened here also, there'll be 10 molecules and they'll be having the same speed. Able to put that one. So I think in SCRMA, yes, defined what do you mean by steady state means the distribution of molecules, the distribution of speed of molecules is independent of space, time, and the direction also. What do you mean by steady state here? At steady state means, so what do you mean by here? The distribution of speed of molecules is independent of position, time, and direction. Means if there are 5 molecules, they are entering here. 5 molecules should leave. With what speed 5 molecules will enter this volume? With the same, means it's like this, with what velocity 5 molecules will enter? 5 different molecules will enter with 5 different velocities. At that instant open, there should be another 5 molecules, they must have different speed, and they will enter with they will leave the container with the same velocity. Means here you can select a V1, V2, V3, V4, V5. Here also V1, V2, V3, V4, V5. So what does it mean? Distribution of molecules is independent of direction. Next again, how many molecules that are here in this? There are 10 molecules are there. They're having velocity in different direction. Here also there should be 10 molecules. They must also have the velocity in same direction like this here. So what does it mean? The distribution of speed is independent of position, time I brought, and also the direction I explained. I think I may not able to, and I'll give diagram like this, better. So therefore, so what you learn behavior of gas at one point, it will have same behavior. Okay, five molecules are entering. At the same time, what happen? Another 5 molecules must leave. Opposite to that, we have to do it. Some other color I'll show it. Okay, this is V1, V2, V3, V4, V5. Similarly, what happened? This should be the V3, V4, V5, V2, this V1. Able to understand now? So this is for this one, independent of time, shall I put it? And the direction. What about position? So suppose say if there are 10, if you compare these two here now, means if there are 5 molecules, they're entering a given elemental volume with a different velocity. There should be another 5 molecules. They should leave the content. They should leave that elemental volume with the different velocities like this. So one molecule is entering with velocity 1. Other molecules should leave here. One molecule, second molecule is entering with a velocity V2. Other molecules should leave V2. If one molecule is entering with V3, it should leave V3. So now at any instant of time, you come and see here the molecules that are entering what pen, they must have this particular velocity, and they're leaving also, they must have this velocity. So therefore, there's a meaning of steady state here. Okay, this is about the time. What about position? Suppose say there are, okay, I think this will be the one more box, we'll take it. So in this container, we have 5 molecules. So they are like this. Moving with speed V1, V2, V3, V4, V5. If you consider another elemental molecule, there also the situation should be same. So look at the distribution of speed of molecules is independent of position also, time, and also you can see the direction. They're the meaning of steady state. And what all we discuss problems at steady state. That's why what you study behavior of gas here, it will have same behavior here also. There is a meaning of this 10th postulate. So therefore, I say pressure of gas. Yes, sir, at any point, the pressure of gas will be same. Okay, getting this one. So you need to bother like a sir, which part? Okay, what we are going to say, pressure of gas is understood. Everywhere pressure will be P. No force of the last one. No. The force of interaction between molecules and wall are negligible. Then what is the overall energy? So shall we say interaction potential energy? should be negligible. So there no interaction potential will come. So we need to bother about interaction potential. So therefore, what the gas will contains, it contains only kinetic energy. Why potential of gas is not taken? Because there is no interaction. When there's no force of interaction, no question of potential. You know gravitation very well. If there's no force of interaction, no potential. So therefore, only kinetic energy we are going to consider it. So therefore, what is the use of this? The total energy of gas is due to kinetic energy of molecules only. Fine. So these are some assumptions. What happened? We are no force of interaction, no attractive, no repulsive. So what about gravitational force? That also will be negligible. You can avoid all that one. Okay, the last one, the molecules. Constantly collide with the walls of container due to which momentum changes. The change in momentum, the change in momentum per unit time will nothing but pressure due to which momentum changes. So molecules will exert pressure on the wall. And there is nothing but we'll call pressure of a gas. Okay, these are some keeping my physics in mind. What happened? I just designed here. These are all the postulates. Okay, of all pressure of a gas means S at any point what you can call pressure, temperature, everything. So what is our next target is like, I want to measure pressure, temperature, and the energy of a gas. So these are the postulates I made it. So let me let me jump into the deriving expression